Hey, geometry students, Mr. Davis here with a supplemental video on simplest radical form. And again, this is being recorded January of 2021. We noticed, and we're kind of looking at distance learning being a factor here. We noticed that as we went through the end of chapter 5, this is all across the board with some of the geometry teachers, that this was a skill that we weren't so great at. And so um, probably could have spent a little more time on it, at least speaking for myself, but also I just wanted to kind of touch base on it again and make sure that we have an understanding of this going forward because it is something that you'll be asked to do throughout the rest of your high school math career. So when it involves square roots, we may be asked to give the answer in simplest radical form. Here's a from the presentation. Here's what that would look like. Give the value of x. Give your answer in simplest radical form. Now, if you're paying attention, you can see this is a Pythagorean theorem section. So we're talking kind of a Pythagorean theorem problem here. And when we do our answer, we're not going to give our answer as a rounded square root. If we took the square root of 40, we would get something a little bigger than 6. But there's also a process called simplest radical form where we have to simplify this and get it down to 2 root 10. And we kind of went through that real quickly when we actually did this the first time. And we think it's going to be worth our time to go back and revisit it. So we're going to talk more deeply about this and then you can come back and take a look at this problem if you choose to. Here's what simplest radical form is. Simplest form of a square root expression. The radicand, that's the part underneath the square root sign, that cannot have a perfect square factor. We'll talk about perfect squares in a few seconds. There can be no fractions inside the square root, and there can't be a square root sign in the denominator. We have to be ready and prepared to deal with all of those examples. So when we talk about perfect squares, we're talking about the numbers to the right of the equal sign. One isn't really doesn't really count here. You can always divide something by one. That's not what we're talking about. But if we can divide out a 4, a 9, a 16, and so forth, we need to do that. And we also need to keep in mind these two rules right here. That if we have two separate radicals that we're multiplying, it actually equals the whole thing. Think of it this way. Going back to our square root of 40 example from the problem before. The square root of 40 equals the square root of 4 times the square root of 10. And that's how we're going to look at that. It also works for division. The square root of a fraction equals the square root of both the numerator over the square root of the denominator. Two examples we're going to look at. I know you can't see this word down here. I'll move myself so that we can take care of that. But we're talking square root of 16. Well, the square root of 16 has a perfect square factor, and it is 36. So we are going to divide out. We're gonna turn the square root of 16 into the square root of 36 times the square root of 6. Why do we do that? So that we can take the square root of 36 and get 6. So this becomes 6 root 6. Now I'm going to exit out of here and go take a look at this problem on Desmos. First of all, let me back up a second. The reason this works in the problem that we looked at, we had root 40 equals 2 root 10. You can see we get the same thing when we evaluate these things if we were trying to round it. And now we'll take a look at the square root of 16 and 6 root 6. Same thing. It's the exact same irrational number. Again, these are decimals, that these are basically irrational numbers. These are decimals that go on forever with no pattern. Let's go back to the problem. And once again, so we factor it out and we get it down to 6 root 6. Now we can't divide out a 6. Now you might ask yourself, what if you didn't know that 36 went into 216? You could have, there are actually a couple other ways to have done this one. Let's say maybe you thought that 4 is a perfect square that goes in there. You'd be right. You could divide this by 4. I want to say that you get, root 4. So you could break it into, root 4 times, I want to say it's root 54 would be what we would multiply that by. And then you would have to see again that root 9 would come out of root, out of that square root, out of root 54. So you may have to do the process more than once. It's no different than if you say simplified 4/8 down to 2/4 and then realize you still have to keep going and simplify it down to 1/2. What I'm saying is, and I didn't include it on the video, probably should have in hindsight, but this process might get done more than once. You may have to, if you didn't see right away, if you divide out the biggest perfect square right away, then you only have to do one step. If you divide out a smaller perfect square, which sometimes is easier to do and see, then then you may have to do the process more than once. Here's a second situation right here. Now we've got the square root in the denominator. Now we have to do a process called rationalizing. And we take advantage of the fact that anytime you multiply by 1, you don't change the value. So we're going to multiply by a very fancy looking version of 1, in this case root 2 over root 2. Why did we do that? Because root 2, remember when you multiply fractions, you multiply straight across. Well, the reason we did this is because root 2 times itself equals 2. And now we have 6 root 2, excuse me, over 2. And then we can divide 6 and 2 and get 3. And our answer is 3 root 2. Once again, if we check our answers here, you can see that 6 divided by root 2 will give us the same thing as 3 root 2. Why do we do this? Well, because there are problems where we're asked to give the answer in simplest radical form. So once again, looking at this original problem, it comes up a lot in Pythagorean theorem type stuff. And you can see here that if we break this up, if we break up root 40, into root 4 times root 10, take the square root of 4 and get 2, that 2 root 10 is the simplified version of this, and that's the answer we're looking for. So that is simplifying, that is simplest radical form. Possibly, I know at least as I'm doing this, I'm giving an assignment that goes with this, with the students with a chance to earn some points at the end of semester 1 and improve your grade, but this video might be getting watched at other points during the year to help people who maybe are just struggling with the concept. This concludes our video on simplest radical form.